It's just a comparison of two, and oftentimes it's more, quantities. It's a comparison of two or more quantities. We're just comparing numbers to each other. Now, a lot of times you see these represented as a fraction. So some ways to represent a ratio, we could just do it as a ration. I'm sorry, as a fraction. I just turned ration in anyway. So A divided by B is a ratio. How does 2 compare to 1? Or something like that. We can also use a colon. So if you ever see A colon B, it means the exact same thing as A over B. So 2 colon 1 is the same thing as 2 over 1. The last way we can do this, we can replace that colon with the word 2. We can use A to B. Those are 3 different ways to represent ratios. Now, note in math, more commonly than not, we're going to go ahead and use that fraction one. So when I think of the word ratio, I think of a fraction. I think A over B. That's what I think of when I hear the word ratio. Ratios can be simplified, just like fractions can be simplified. So if I look at 8 over 12, I probably don't want to deal with 8 over 12. I could simplify that. Does anyone know what I can simplify 8 over 12 to? Yeah.
2 over 3.
2 over 3, because 4 goes into 8 2 times. 4 goes into 12 3 times. So we just look for a number that goes into both numbers evenly. Now, even though this isn't a fraction, we know that is a fraction. This is really 40 over 24. It's just a different way to write it. So we can simplify it. Does anyone see numbers that go into 40 and 24? Or give me how it simplifies to? One or the other. Just give me a number that goes into it, or give me the finished thing. Yeah. You're saying what? 5. And we actually use the word 2. That's why I kind of wanted to bring that up. So even though we don't write it, we still say 5 to 3 there. So I think we saw 8 went into 40 5 times. 8 went into 24 3 times. So 40 to 24 reduces to 5 to 24. Now, just like with the colon, we can, if possible, 51 to 39. Does anyone see a number that goes into both of those evenly? Or knows how it simplifies? Here's a question. Does 3 go into both of them? Do you already have it? Yeah, this one's a harder one to see. It's actually 17 to 13 because 3 goes into both of them. Do you guys know the 3 trick? What was that? It's just like reducing fractions. Now, for those of you that said, no, you don't know the 3 trick, if you add up all the numbers that comprise it, so 5 plus 1 is 6. If 3 can go into that, it can go into the big number as well. So 3 plus 9 is 12. 3 can go into 12. So you're perfect there. And you can keep working your way down. 3 plus 9 is 12. 12 is 1 plus 2, which is 3. 3 must go into it. It's a nice little trick, especially when you get to big numbers that look... 51 almost looks like nothing goes into it. So if I don't think anything go into it, I usually think of the number 7 or 3. Those are the ones that come up with those weird kind of numbers. All right, so we can reduce any proportion, whether it's a fraction, whether it's a colon, whether it's the word 2. Now we're going to build up to something called a proportion. We actually have proportions up here. This, you guys good? Yeah. All right, this is actually a proportion. This right here is a proportion. So 8 over 12 equals 2 over 3 is a proportion. It is just an equation. So we have an equal sign. That's all equation means. That states 2 ratios are equal. So we just have an equation that says the 2 things are equal. So if I write 8 over 12 equals 2 over 3, that is now a proportion. It's 2 ratios on both sides of an equal sign. That makes it a proportion. A proportion is written as, now typically for us, we're going to write it as A over B equals maybe C over D. It's just two ratios with an equal sign between it. So when I think of the word proportion, I immediately go to, oh, that's a fraction equals another fraction. Now, when you have a fraction equaling another fraction, I have a fraction on one side and a fraction on the other side, that introduces an algebra concept called cross multiplication. It's also called means extremes. We're not going to get into that. We don't really have time to go through a different word. So we're just going to call it cross multiplication in here. Cross multiplication says that, you know what, if A over B equals C over D and I cross multiply, I can rewrite this as A times D equals B times C. And that's going to be the important thing today. The cross multiplication is going to be our big thing today. We're going to be able to set these proportions up, but we're going to actually be able to solve for stuff by using this cross multiplication. So once again, if I think proportions, I'm also thinking, okay, fraction equals a fraction, but I'm thinking of cross multiplication. So when I see a proportion, I should immediately think of this, that this is true as well. Because we'll have problems where there's missing values. So if I have 4 over x equals 2 over 7, to solve this, we're going to use cross multiplication. A lot of times I draw my arrows. So we can have 4 times 7 equals x times 2, which I'm just going to write as 2 times x, because usually we put that number out front, because then we have 2x. All right, then we just have to do 4 times 7. That's 14 plus 14. I think I got 28. Did I do that right? We're good. Equals 2x. Divide both sides by 2. And I came out with x equals 14. Are we on board with x equaling 14? Okay, let's try C. Now, C creates a completely different situation. Notice I have x minus 1 on top. I have x minus 1 on top. When you do your cross multiplication, when I do my x minus 1 times 19, this 19 has to go to both elements. That 19 has to go to both elements. So the way I'm writing this one is I'm going to still do this kind of thing, but I have that 19 times that x minus 1. I'm going to write this as 19 times the quantity x minus 1 to remind myself that it has to go to both elements. You do not have to write it. Some people do it in their calculator where they just go, oh, it's 19x minus 19. That's fine. But understand that we're multiplying that 19 by everything. And then we have the 6 times 13. All right, so this 19 has to get distributed to both things. So I now have 19x minus 19 equals 6 times 13. That must be 60 plus 18, which equals, I heard it, 78. Now we're adding 19 to both sides. Remember, we're adding 19 to both sides because this is a fraction, so we change it to addition. And all of a sudden I have 19x equals, here we go. Thank you. Is going to equal, well, we're going to have 80 plus 9, so we're going to have, what, 97? Does 19 go into 97 evenly? I don't know. Take out a calculator. 19 times 5 is 95. So it doesn't go in evenly. So what should we probably be taking out? We should probably take out a calculator, not just estimate this. Don't just guess at it, take out a calculator. And don't be lazy, take out a calculator. What was that? Nope, we're not doing remainders. We're doing decimals. What does that come out to? It comes out to a decimal. What is the decimal? It's 5.1. This is x equals 5.1. No remainders, just 5.1. Plug in your calculator and check it. Do B and D. So we should have done 10x equals 19 times 12. What's 19 times 12? Did anyone get that? Yeah.
228.
228. And then when we divide by 10, you should have came out with x equals 22.8. Am I correct at 22.8? All right, cool. Our next one. Now, remember, when I do this multiplication, this 5 has to go to both the x and the 4. So I should have something like 5x at some point plus 20 equals, what's 17 times 19? Yeah. 323. Then we subtract 20, so we have 5x equals 303. I guarantee you 5 doesn't go into that evenly. Can someone raise your hand and tell me what x equals on this one? It's not yet. 60.6. Can I get a second on that? We agree with that? All right. There we go. That's cross multiplication. If you can't do this, you can't do the rest of the section. All right, and good luck on the quiz. We got to know how to do cross multiplication. All right, Julian, you got doing something? Oh, okay. It's a big calculator. All right. That leads us to similar polygons, particularly triangles, but this works for any polygon. Polygons, like triangles, so triangle is an example of a polygon, with the same shape. All right, in order to be similar, you must have the same shape. So a triangle can only be similar to a triangle. It can't be similar to a square. It's got to have the same shape. Now, to be congruent, two triangles need to be the same shape and size. What we're changing here is polygons, like triangles, will have the same shape but different sizes. So the way I picture that is, I picture a magnifying glass. When you take a magnifying glass up to like a picture, it makes it bigger or smaller depending how close or far away you are. It's still the same shape, it's just the proportions are different. It's still proportionally equal, but it's going to be one's bigger and one's smaller. So polygons are going to be similar if all of the angles must be congruent. So that doesn't change from congruent triangles. All of our angles must be congruent. So corresponding angles are still congruent. Corresponding angles are congruent. And I'm going to box in that word congruent because that's important. So that's just like two congruent triangles. Two congruent triangles have congruent angles. Two similar triangles have congruent angles. So if we go to this drawing over here, I could put some marks on this. I could say something like, I could put my marks like this and this. I could put my double here and here. I will note on the quiz, a whole bunch of you lost points because on specific problems I said mark your congruent statements, and a lot of you just didn't follow the directions. So if I ask you to mark your congruent angles here, that's the way it's going to look. Now, our corresponding angles are congruent. Our sides are not congruent. If they were congruent, they'd be congruent triangles. But they're going to be proportional. So corresponding sides are proportional. Proportional. And what that means to you is we're going to create a long proportion statement. So if you look here, the side A over B, that fraction must equal C over D, which has to equal E over F. They have to be proportional. In other words, if this triangle is twice the size of this one, I should be able to multiply all the sides by 2 to get to that big triangle. If this was 3 times the side, I should be able to multiply all of the sides by 3 to get to that bigger triangle. Now, that leads us to kind of a problem. You can't mark the sides as congruent because they're not congruent, so we can't put tick marks on this. So it's kind of up to you on how you want to decide how to say that these two sides are corresponding. What I typically do is I use geometric shapes. So a lot of times what I'll do is I'll circle maybe my C and D values. Maybe I'll put a box around my A and B values. maybe I can put a triangle around my E and F triangles. That way I can see which ones are my proportion ones that I'm comparing. Because you could start picturing, we're going to have some of those missing, and we have to find those. Another thing that's going to help you when dealing with similar triangles is notice how A, C, and E all come from one triangle, and B, D, and F come from the other triangle. Now, it might not make sense now, but when we get to the problems, what I'm actually going to start doing is I'm going to start labeling one of the triangles as top. That way I know all the sides are going to be the top of my proportions. So right now, if I labeled that top, I know that A, C, and E must be on the top of all of my ratios. That's important because you can't flip them. Once you pick one triangle to be the top, they must be the top of all the proportions. All right, the ratio of the sides is going to be called the scale factor. And for anyone that does models, you know what a scale factor is, because they'll say, like, if you're building like a model car, it's like 1/30th an actual size of a car. That's your scale factor, 1 to 30. That you would divide all the actual proportions of a race car by 30, and you'll have your model. Well, if polygons are similar, now this is kind of a weird thing, then their perimeters are also proportional. Their perimeters, I think I spelled that wrong, 100%. 100%. Yeah, it should be perimeters. That is one of my bad areas. All right, our perimeters are also proportional. So if I ask you what's the proportion of your perimeters, you just need the proportion of two sides, and you have your proportion of your perimeter. So you will note in the homework also to say something about perimeters. You're going to have to go back to your notes to rehash what that means. All right, let's continue on. Scale factor. I said scale factors are the most important thing to go from one triangle to another. So our scale factor. Our scale factor, and like I said, order matters. That means one triangle must be the top. So that's what that order matter means, is one triangle must be the top. One triangle must be the top. So that I know every single time I talk about that triangle goes on the top of the proportion. Most of the time you get to pick which is the top and bottom. Some problems tell you what has to be the top and bottom. So if we look at this, it says, what is the scale factor of ABC to DEF? Notice the first one given needs to be the top. So if I write out what scale factor order I want, the first thing I state is your top of your fractions. So I'm going to go over here and I'm going to list this as my top. Now I'm going to look at the sides that are corresponding. Well, our corresponding sides, so notice how this is 1 tick mark to 2 tick marks, A to B. This is 1 tick mark to 2 tick marks. So my corresponding would be this 8 and 12. It would also be this 10 and this 15. It would also be this 14 and this 21. If these triangles are actually similar, I should be able to write a proportionality statement that crosses all of them. So I should be able to write a statement that goes 8 divided by 12, because those are my two sides. I put 8 on top, because that's my top triangle. I'll put 10 over 15. And then I'm going to have 14 over 21. What does 8 over 12 reduce to? 2 over 3. What does 10 over 15 reduce to? 2 over 3. What is 14 over 21? 2 over 3. So your scale factor is 2. It will always be that. Now, I just want to show this to you that if I tell you that they're similar, you just have to pick two sides that are corresponding. So for the scale factor, it really is just 8 over 12 equals 12 over 3. You get to pick any sides you want, and that's your scale factor. If I say they're similar, you don't have to do this check. I'm just showing you that you get to pick out any sides you want, and that's your scale factor. It has to be. Because if I say they're similar, this must be true. So your job is just to get the 2 over 3. So if I was doing the problem in the homework and it said, what's the scale factor? I'd probably just do 8 over 12 equals 2 over 3 is 2 over 3. I wouldn't do the other ones because I said they're similar. Will, does that make sense?
Yeah, but you don't know the answer to this.
So
you said you do 8 over 12 equals 2 over 3.
Yeah, our scale factor is 2 over 3.
You found that out by doing all of them.
I did not. You just need any one of them. Because 10 over 15 equals 2 over 3. 14 over 21 equals 2 over 3. So if you picked 8 over 12 and you said that equals 2 over 3, awesome. If Julian next to you picked 10 over 15 and he said that equals 2 over, he's good too. You just need to pick out 2 sides. Okay? All right. Then the next one says, what is the scale factor of DEF to ABC? So that would change DEF to be in the top. How would that change my scale factor, or would it remain 2 over 3? What do you think?
It's going to switch. It's going to be 3 over 2.
It's going to be 3 over 2. Thank you. It's going to switch to be 3 over 2 because that becomes our top and that becomes our bottom. So one more time, if you get to pick which is your top and bottom, Joseph might pick the small one to be the top, and Grant might pick this one to be the top. You'll still come up with the correct answers. It's just your scale factors are going to look different. Your work's going to look a little bit different, but at the end of the day, you're going to have the same answer. So if I don't tell you what your scale factor has to be, you get to pick which is your top and which is your bottom. But you have to pick one to be your top. All right, what is the ratio of the perimeters of DEF to ABC? What is the ratio, if DEF is my top, of perimeter to the other perimeter? What was that?
3, 2.
It's 3 over 2. I just said that. I just said, don't forget about this, that if polygons are similar, their perimeters are also proportional. So it's the same proportion. It will be 3 over 2. So whether I talk about sides or perimeter, it's going to be the same. Whether I say what's the side proportion or what's the perimeter proportion, they're both the same scale factor. All right, similarity statement, and then we'll get to some examples. Similarity statements. A valid similarity statement must match corresponding angles and sides. Hang on, real quick. The symbol for similarity is that guy. Isn't that the top symbol for a congruent statement?
Yes.
Huh. It's almost like a congruent statement has a similarity statement built into it. Because a congruent statement has to be all the angles are congruent and all the sides are congruent, which also means they're proportional. So this is just saying, well, all the sides aren't equal this time. That's why it's different than being congruent. Similar is like congruent, except we don't have equal, we have proportional. All right, so that's our statement there. Then it says, well, what's the similarity statement for the triangle up above? So just like we would if I was doing a congruent statement. If I did a congruent statement and I said ABC is congruent, what triangle would you pick to be congruent to ABC? Raise your hand and tell me what's congruent. If this was a congruency statement, what would I put to ABC? Joseph? I'd put DEF. The same is going to be true for a similarity statement. So those of you who know how to do the congruent statement, this one's going to be just as easy. I'm going to go triangle ABC. Except for this time, instead of a congruent symbol, I'll put that little tilde there. And we're going to have triangle DEF. So order matters when we name these. And I feel like almost all of us have that down pretty good.
If we have a question, it's like saying, what's the similarity statement, and we accidentally do the congruent symbol, is that like...
That'd be bad.
Okay.
Yeah. Okay, so this says list all the congruent angles and write a proportion that relates to the corresponding sides. Okay. So we just have to look at these and go, okay, J must be congruent to P. So we're going to go ahead and start making our marks. J must be congruent to P, so we'll put a single mark there. We'll have K is congruent to M because the order they're put in, so we'll put a double on K, a double on M. And L to N, we'll have a triple on L and a triple on N. So our angles must be all congruent. So we can go ahead and make statements like, you know what? Angle J is congruent to angle P. I can say angle K is congruent to angle M. I can go, where we left? L and N. Angle L is congruent to angle N.
So how come you don't use that squiggly?
What squiggly sign? I did. I have that congruent. These are congruent. These are similar triangles, but the angles are congruent, 100% equal. So, Will, if I tell you that J is 33 degrees, you could tell me that P is also 33 degrees. Okay, so angles are always congruent. You need to know that because that's going to be part of questions. All right, then it asked for a proportion statement for the sides. So now we just got to state corresponding sides. But remember, we do have to have one of these triangles as a top. So when I'm naming these, I'm going to say anything that I refer to on this triangle is my top. So my sides, proportional statement could be JK over, well, J is 1 to 2, so 1 to 2 would be PN. That'd actually be my scale factor, right, Matt? Yeah.
Wouldn't it be PM?
Oh, yeah, PM. Sorry, thank you. So 1 to 2 is PM. You might want to get some of this down. All right. So we have, what do we have? We have JK PM. Say that again. KL, and you said MN. 2 to 3, 2 to 3. I like that. And then what's our last one? JL. So that's 1 to 3, and then you said PN. Cool. And any one of those would be our scale factor. Any one of those would be our scale factor. So if I knew any of those values, we'd be good. I'm going to skip this next one. If we have time, we can go back to it. But it's the same thing, except for now you have 4 angles that you can say are congruent. And you could have 4 congruency statements up there. So I'm going to skip that one. If we have time, we'll come back. I just have more important things I want to get to. And particularly, it's this one. This is what we're building up to. How do we use proportional statements to find missing sides? Now, when we had congruent triangles, it was super easy. I could say all the sides are congruent, so if one was 2, the other one's 2. Well, it doesn't work out that way. Instead, we have to use the scale factor to find a missing side. So this says, in the figure below, are similar with a scale factor of 2 to 3. So I'm assuming, based upon this, that this must be my top. Because they said 2 to 3, that creates a fraction of 2 over 3. Find the value of x. So if 2 over 3 is my scale factor and that's my top, we're going to set up a small equation. We're going to go, well, that means 2 over 3 is proportional to the sides. So my sides would be 42 over x. That's why I always pick one to be top and one to be bottom, because I knew to write this. I know it's 42 and x. We just got to be clear that the 42 goes on top and the x goes on bottom. We're going to do a quick cross multiplication here to get us 2x equals, what is that, 126? Okay. And then we divide by 2, and x would equal 63. What was that, Ty? Okay, cool. So we have x equals 63. This one is not one I'd put on the test. Because do we know what parts are actually proportional? No. So we're going to take it on faith that the ones that were given are proportional ones. That's not going to happen a lot. And they tell me that it's 6 to 5. That must mean that the first shape is our top and the second shape is our bottom. So we're going to have 6 over 5 equals, since this is my top, I'd have x over 28. We're going to do 5 times x and 6 times 28. So see how this is 6 to 5? I'm going to assume they meant the first shape is my top and this is my bottom. So any value I pull out of here is going to go on the top of the fraction, Any number I pull out of here will go on the bottom of the fraction. That's why we call it top and bottom. It makes your life easier. All right, so we're going to have 5x is going to equal 6 times 28. I shouldn't see shoulder shrugs. You all have calculators.
68.
168. Thank you, one person. And so we're going to have x equals what?
33.6.
33.6. Can I get a second on 33.6? Yes. All right, cool. All right, like I said, these aren't really testable questions. I'm just showing you that if you have a scale factor, you can find missing sides. So the real big questions you're going to see on like a test are ones that look like this, where you have to come up with a scale factor. You have to find the missing sides based upon the scale factor. Now, here's my advice to you. When I ask you to find missing sides and angles, find the angles first because they require no work. Your angles require no work. Now, based upon how this says, so all shapes that appear similar must be similar, so this must be drawn correctly. So we can go ahead and put little marks and say, oh, that 42 matches the y. The 80 matches the x. And the 58 matches the 58. So if I'm making my marks, I can go, oh, you know what? Y is just 42 degrees. Don't get that one wrong. If I ask for angles, don't get these wrong on similar shapes. They don't require a scale factor. You just go straight to them. So that means our x is going to be that 80 degrees. To find a missing side, you need a scale factor, which means you need to call... Did I tell you what the scale factor is to this one? No. So that means you need to pick one of these triangles to be the top and one of them to be the bottom. So I'm going to let you decide. Who wants this one to be the top? Who wants this one to be the top? Looks like people want this one. So we're going to call this one the top. Now, Will, we talked about this before. You get to pick any side that is corresponding. So if I look at 35 and 14 and 40 and 16, I can pick either 35 over 14 or I can pick 40 over 16. They both will result in the same answer. So someone tell me, which one do you want? Do you want 35 over 14 or do you want 40 over 16? 40 over 16. I challenge you, pick the other one and see if it comes up to the same answer. What does 40 over 16 reduce to? Oh, I heard a lot of different answers. 2.5, but I need a fraction. 5 over 2 is correct. 5 over 2. That is my scale factor. If you would have picked 40 over 16, 40 over 16 reduces to 5 over 2 as well. All right, that is now my scale factor. Now we're going to go, let's use our scale factor. And the fact that I called this one the top. So notice how 25, let's put our triangle around 25, corresponds to B. And since 25 is on our top triangle, we're going to pick this as 25 over B. So I take that scale factor, top and bottom, and I use the sides top and bottom to match up. That's why we always label it top. I will tell you, people on a test that don't do this typically get them wrong. They just kind of guess at how they're going to do it. Just label one top. It doesn't take a long time. All right, now we do our cross multiplication. I have 5b. Correct me if I'm wrong, but I'm pretty sure 2 times 25 is 50. Pretty sure we didn't need a calculator for that. Divide by 5, and we're going to have b equals 10. So we can go over here and say, oh, my b equals 10. I'm going to give you just a couple minutes. Try the next one. Remember, all angles. Now, you got to be clear. P is congruent to W. Q is congruent to X. R is congruent to Y. S is congruent to Z. So I'd make my congruency marks first to get the angles. Then I would get a scale factor, and then I would try to find the missing things. We don't have doing anything. Question how you're doing math. Because math is about making mistakes, not just waiting for the teacher to give you your answer. All right, so the angles should have been pretty easy, and I'd make sure I put my marks on here. So I'd go P is congruent to W. Oh, that's my A value. My A value is 81 degrees. All right, cool. Then it says Q and X. So Q double, X double. Doesn't give me anything, but I at least have my marks on there. R goes to Y. So I go triple. Oh, that's my b values, 50. And then I should mark my last one. All right, it doesn't matter which one you call it, top and bottom. I don't know why. I typically pick the smaller one to be the top. Doesn't have to be. I usually just like the smaller one on top. For whatever reason, I like 2 over 3 versus 3 over 2. Okay, so that's my top. Now I have to realize which parts are corresponding. The easy way to come up with corresponding parts are, well, my x goes from 3 tick marks to 4. Well, this 32 goes from 3 tick marks to 4. So I'm going to go ahead and circle both those and go, okay, those are corresponding. But that doesn't get me a scale factor. I have one of those missing. So then we look at the 75. 75 goes from 1 to 3. Well, 40 goes from 1 to 3. So 75 and 40 are also corresponding. So I'll box that. And so my scale factor is actually going to be with 40 over 75. Who had 75 over 40? You should get the same answer I get out. Who simplified this fraction? Who did not simplify the fraction? I think you should still get the same answer whether you simplify it or not. What does 40 over 75 simplify to?
2 or 3.
8 over 15. Did I hear 2 over 3? Yeah, 2 over 3 couldn't work because that means 20 doesn't go into both of them. So 8 over 15 is correct. Now, note, if you're not sure of your simplification skills, I could set this up as 40 over 75 equals, and it looks like the 32 comes from my top, and you get the same answer. The only reason why we reduce it is to make our life a little easier with calculator usage, but it doesn't matter if you reduce it or not. So if you're not sure of your reducing skill, just leave it as 40 over 75. There's nothing wrong with it. There's nothing in the problem that says you have to reduce your scale factor. So my scale factor could be 40 over 75, or it could be 8 over 15. All right, let's do our cross multiplication. I know it's going to be pulling teeth, but you guys can help me out here. What's 15 times 32? 480? Are we all good with 480? Okay. And when I divide by 8, what do I come up with? 60 should be correct. So our x is 60. Not degrees, but 60 because it's a length. All right, I have about 9 minutes to get to this next one. This next one's really, really interesting. This is one of our overlapping triangles. Now it says BNV is similar to BRG. So if I'm looking at this, when I look at BNV, I'm going to highlight it. I'm looking at that triangle there. And then they talk about triangle BRG. So I'm going to go ahead and I'm going to draw the other triangle. I'm going to draw BRG. And I'm going to put any number they have on that. Do they really have any numbers on BRG? But what do they have above this? What do they tell us about length BR? Equals 20. So I should probably put a 20 on here, right? Okay, so they did have a value on there. I'm going to call the little red triangle the top. And we're supposed to find, what are we supposed to find? We're supposed to find VG. We're supposed to find RG. Let's call RG X. We're supposed to find BG. Let's call it Y. And let's call this VG just Z. It'll help us just keep things straight. Is there a scale factor we can get between these two triangles? What we're looking for are two numbers that are in corresponding spots on both of these triangles. Does anyone see two numbers that are listed for two sides? Yeah.
20 and 12.
20 and 12. Let's look at 12. Let's circle 12 and go, okay, that's that long side. That corresponds to that one. If you're not sure about that, just look at your name. It says BN and BR. So BN and BR must be corresponding spots. So I circle BN and BR. I'm also going to notice 10, and x are going to be corresponding spots. Yeah.
Can we make like a separate like triangle because it looks kind of confusing?
Sure, like a small triangle off to the side. Absolutely, yep. You could draw whatever you need to help you. Yep. So I'm going to go 10 corresponds to x. And I'm going to look at that 8. I'll put a triangle around that 8 that corresponds to the y. So notice I have two numbers to create a scale factor. And I have things to find all of those missing pieces. So if that's my top, what's my scale factor? Someone besides Hogan, because he gave me those two values. What is my, raise your hand and tell me what the scale factor is for this particular problem. What's the scale factor? These 4 people. Remember, we got a quiz coming up real quick already. We want to try stuff. Savar? 3 over 5, which came from probably that 12 over 20, right? Which equaled 3 over 5. That's my scale factor. That's going to be the thing that connects everything to each other. So because that 12 and 20 match up, I can go 12 over 20 equals 3 over 5. Okay, so that connects everything. So I'm going to go 3 over 5 equals, what do I put on the other side to solve for x? Raise your hand and tell me what I'm going to put on the other side to solve for x. Kai? 10 over x. Perfect. So we have 10 over x. We do some cross multiplication. That's going to give me what? 3x equals 50. Does 3 go evenly into 50? No. So that means we need a calculator.
16.6.
And x equals 16.6. And remember what our x stood for? It's our RG. So RG is going to be 16.6. Okay, let's use the 3 over 5 again. Guys, if you can't sit next to each other, tell me now. Yeah. Oh, is it a repeating decimal?
Yeah. Or no, it was like 10 and then it went to 7.
It was 16.6 repetent? So it's 16.6 repetent. So we'll just put a little dash above it. Okay. What did I mess up on mine? Oh, I see what I did. Yeah.
So a number is like infinitely repeating. Do we have to put that line in?
No, we're probably just going to approximate it from future. So we could probably put 16.7 on there as well. In fact, let's just change that to 16.7. Okay, so to get BG I labeled as y. So we can go 3 over 5 equals, what equation is going to give me my y value? What was that?
3 fifths, 8 and 8 over y.
And 8 over y, yeah, because this is my top, so we'll do 8 over y. I see what I did on mine. I flipped all the wrong values. Okay, so we have 3y equals 40. What is y equal to the nearest tenth? Because that's going to come out to a weird value as well. What did you get? 13? 13.3 then. We'll go about 13.3. We're on to the nearest tenth. So this one's going to be 13.3. Now we have 2 minutes to figure out how we're supposed to get z. Yes, Joseph. Elio, how'd you get that? Oh, so we could just, because we know the full length. So we know this whole length here is 13.3. So to get z, we just have to subtract 8 away from it. So our z is going to equal that 13.3 minus that 8, which equals 5.3. So the last one is 5.3. Hey, guys, I just want to reinforce the idea that we have quizzes, not tests. We don't have review days. You need to go home and you need to do this homework. You need to understand it. You need to come with questions tomorrow.
What
Or I should say on Thursday. But we can answer questions tomorrow as well.
What's the first piece?
It's on your sheet.
Which is